Welcome to my channel RAVIKUMAR Academy. This is a lecture series on matrices, lecture number 12. In this lecture, we are going to learn how to find the characteristic equation of a given matrix and its eigenvalues. So this is a shortcut to find the characteristic equation. For example, you are given a matrix A, matrix of order 3 will be like A11, A12, A13, A21, A22, A23, A31, A32, A33. Right. Now, the characteristic equation of this matrix will be looking like lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So, what are S1 and S1, S2 and S3 here? So, what are S1, S2, S3 here? Here, S1 is the trace of A. What do you mean by trace? Trace is sum of the principal diagonal elements. A11 plus A22 plus A33. So, sum of these three elements is S1. Then, coming to S2, what is S2? S2 is sum of the determinants of the cofactor matrices. So, it is the first one is the minor of the element A11. Right. So what do you mean by minor of the A11? You leave this column and this row. So what you will get? The remaining matrix is this. So you take the determinant of that particular submatrix. Okay. Then what you will get? A22, A23, A32, A33. Next, coming to the second one, the cofactor matrix determinant of A22. So leaving this column and this row, what you will get? These four elements. These four elements. So write down those four elements here. So they are nothing but A11, A13, A31, A33. Then coming to the cofactor matrix of A33, it is this one. Leaving this row and this column, you will get the remaining submatrix as this. So now you write that submatrix here. It is A11, A12, A21, A22. Right? Now you find these determinants. You will get the value of S2. And what is S3? S3 is determinant of A. So when you substitute S1, S2, S3 back into this equation, you will get the characteristic equation. Now let us solve a problem. Here given this matrix, the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So how to find S1, S2, S3? Just now we have discussed S1 is trace of A. So what is trace of A? Trace of A is sum of the principal diagonal elements. It is minus 2 plus 1 plus 0. It is minus 1. So S1 is minus 1. Right? Next, coming to S2, S2 is sum of three determinants of 2 by 2 order. Right? This one, 1 minus 6 minus 2, 0. 1 minus 6 minus 2, 0. The previous slide we have discussed it just now, right? Plus This is minus 2, minus 3, minus 1, 0, all corner elements. Minus 3, minus 1, 0, plus top corner, minus 2, 2, 2, 1. Minus 2, 2, 2, 1. So this is equal to, the determinant is 0 minus 12 plus 0 minus 3 plus minus 2 minus 4, which is equal to minus 12 minus 3 minus 6, which is minus 21. So therefore S2 is minus 21. Now coming to S3. What is S3? S3 is the determinant. S3 is determinant of the given matrix A. So it is equal to determinant of the given matrix is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. In fact, you can find the determinant of the matrix A by using the calc itself, right? If you are allowed calc in the exam. Now this is minus 2 into 0 minus 12 minus 2 into this one and this one you leave, you will get 2 minus 6 minus 1, 0 determinant. It is 0 minus 6 minus 3 into minus 4 plus 1. So it is 24 plus 12 plus 9 equal to 45. So S3 is equal to 45. Now substitute these values back into the equation. You will get lambda cube minus S1. What is S1? S1 is minus 1. Lambda square plus S2. S2 is minus 21. Lambda minus S3. It is S3 is 45. So therefore the characteristic equation is lambda cube plus lambda square minus 21 lambda minus 45 equal to 0. So using calc, if you find the characteristic values or eigenvalues, what you will get? You will get 5 minus 3 and minus 3. So you can use calc to find these values, right? 5 minus 3 are the eigenvalues of the given matrix A. Right? So this is how you can find this by using this equation. You need not do a laborious calculation by subtracting lambda and all. You can find the characteristic equation easily in this way. Okay. Thank you so much. Please subscribe to my channel. Also like the video, share it with your friends and comment your feedback. Thank you so much.